Let's discuss the role of temperature and time on the microbial growth in food. A reminder again of the 6 important factors that impact microbial growth in food. Here we'll focus on time and temperature. There is a wide temperature range in which most microorganisms can grow. This is referred to as the temperature danger zone. It is important to keep foods out of this danger zone temperature range to minimize microbial growth and potential food safety issues. All microorganisms have an optimal growth temperature, a temperature that they grow best. When we reduce the temperature from this optimal temperature, microbial growth can be slowed or even stopped. Refrigeration stops growth of many microorganisms, but not all. Freezing will also stop the growth of microbes, but it does not kill microorganisms. If we increase temperatures above the optimal growth temperature, we can inactivate microbes in food. This is why cooking to specified temperatures is important for many types of food that may harbor pathogens. It is also why we have specific temperatures to achieve during boiling water and pressure canning. This graph models the growth of salmonella in food. The horizontal axis is time in hours, and the vertical axis is the level of bacteria in the unit's colony-forming unit per gram. This level of bacteria is on a logarithmic scale, meaning that each whole number is an increase in 10 bacterial colony-forming units. We start the curve here at 3 logs, or 1,000 CFU per gram of salmonella. The yellow line represents salmonella growth at 40 degrees Celsius, the optimal temperature for this particular bacteria to grow. You can see within 8 hours, there is over 100 million colony-forming units per gram of salmonella in the food. If we reduce the temperature to 20 degrees Celsius, salmonella growth slows significantly. Within 8 hours, there is only an approximate increase of 10 colony-forming units per gram. However, if we hold this food for 16 hours at 20 degrees Celsius, there is 1 million colony-forming units per gram of salmonella. This emphasizes a key concept, the combination of temperature and time in influencing microbial growth. Looking at the green line, which is food stored under refrigerated temperatures, there is no increase in salmonella. Refrigeration temperatures stop the growth of salmonella. However, this is not true for all pathogens. Listeria monocytogenes, for example, has the ability to grow at refrigeration temperatures. Bacteria, yeast, and mold require time to be able to replicate in food. When we talk about microbial growth, we mean increasing numbers of microorganisms, not an increase in size. Under ideal conditions, a bacterial cell can divide every 15 to 30 minutes. Ideal conditions again include appropriate nutrition source, appropriate acid levels, optimum temperatures, and a relatively high water activity. This is the same graph I previously showed, but with an increase of time. The red dotted line shows where the time on the previous graph ended. You can see that if we extend the amount of time we hold food at 20 degrees Celsius, at approximately 30 hours, we have the same level of salmonella in our food as when we held at the optimum temperature for 8 hours. Just to give you another example of the importance of time, if we have a bacteria in our food that has a doubling time of 30 minutes, if at 8 a.m. there is 1 bacterial cell in our food, at 6 p.m. there will be over 1 million bacterial cells in our food product. Ensuring that your food is not held within the danger zone temperature range for any prolonged period of time can significantly reduce microbial growth. Think about this when you're cooking, cooling, hot holding, and thawing food.